Hey, everybody. Welcome to Oregon State University's Permaculture Design Pro class. Great to have everybody here. This is the fall and winter course, and I believe this is our fourth office hour. So thanks, everybody, for showing up. I know you guys are all very busy, and it's great to have you all here. And thanks for everybody who's decided to be on video. It makes it a much more interactive experience for me, so I appreciate that. Today, we're going to go through a number of questions. And they're very involved questions, or could be. So if there are subsequent questions because of them, feel free to ask. And I will do my best to answer them all. A lot of these questions came in at the last 5 or 10 minutes. So this is my request to have questions in earlier, because then I can precog quite a bit more and just deliver a better answer. So wherever you can, please do that. All right. Let's jump in, and welcome to everybody. So nice to have everybody here. Nice to see you. So we're going to start with Michael from Korea, and I'm just going to share my screen. So I'm going to come down to a single screen, make me a little bit bigger. There we go. Awesome. So I'm running into a lot of difficulties analyzing my microclimates. It seems I'm having trouble classifying how much sunlight, moisture, and wind each zone is receiving, since all are changing every hour and every season. By what standard should I classify a lot or partly? A standard, for example, may be something like 50% of the land exposed to sunlight 50% of the time during the day is considered a lot of sunlight. Maybe I'm approaching all this from the wrong direction. I link to my sector compass, for I have not made any progress in microclimate. So it's a great question. Microclimates, there isn't a standard metric when it comes to either moisture, temperature, or sun. It's really about starting to build a comprehension and understanding that within our sites, there are smaller areas that either have more or less sunlight, more or less temperature, more or less water, and also shade. So when we're taking a look at a site, there's a number of tools we can use to assess the site, and we'll get into a bit of those. But generally what we're doing is trying to become more conscientious about the site. So for me, currently I've got a big rectangle lot that I'm on, which is sub an acre, and it has pretty good fences. And so I know right beside those fences, because it's a north-south lot and we've got, we basically have fences on all sides. I know on the north and southerly sides, we're going to get a shadow on the inside of that fence pretty much throughout the entire day. On the rows that run north-south, we're going to have shadow on one side during the morning, no shadow at noon. We're going to get shadow in the afternoon and evening. And depending on if we're in the summer solstice or the winter solstice or close to either or the equinox, the angle of that is going to differ as well. So we'll get a little bit into solar assay today. When I'm taking a look on site, I know that some of the areas of my site are lower in elevation in terms of the grade or the ground level. And if the grade level is low, when generally the whole site is flat or sloped, but in some areas it drops down, generally those are the areas that are going to accumulate more clay. And this has to do with the fact that raindrops are violent affairs if you are a soil ped. And a soil ped, again, is a soil molecule that is sand, silt, and clay. So if we have the percussive effects of a raindrop that comes down and hits a soil ped, it breaks apart the sand, silt, and clay and then puts it into solution. And when we have overland run, all of that solution comes with it. So sand, silt, and clay are now in solution running overland. And until we get to a point in the landscape that goes from convex to concave, that solution is there's nothing to stop what's in solution within the water to want to settle down and put in and start to create roots, so to speak. So if we go from convex to concave, a low-lying area, and we'll actually come back to the same explanation when we talk about key point if we get there today. What'll happen is we get to that moment, and all of a sudden, that's the first moment that the material has a chance to settle out. And this is why when we're taking a look at convex to concave areas within our landscapes, generally we're going to find clay, because what'll settle out first is the sand, then the silt, and then the clay being the smallest and the lightest particle, the sand being the largest and the heaviest particle. So when we have low-lying areas, generally if they're micro, let's say in an urban landscape, or macro in an acreage or on large stations, what'll happen is those areas will be low-lying and they'll have clay. And so they're low and they have clay and they tend to hold water. So generally what we're doing is we're evaluating our sites through our senses and through our experience of our site. If we haven't been on our site for very long, we don't have a lot of data to translate that into, oh, this is a microclimate. But generally we're walking and we're looking around, and generally we're going, yeah, it's interesting. When it rains a lot, there tends to be these little areas that pool water. Those are areas that we would consider wetter areas or low-lying areas or moist areas, depending on the terminology we're wanting to use. Generally areas that are open to sunlight. Anything that's over 6 hours, we're going to say is rather sunny, with the understanding that most fruit trees and fruit shrubs and fruiting plants are going to want somewhere in the order of 8 to 10 to 12, of course, with more sunlight usually being preferable. There are some exceptions of some fruits that like a little bit less sunlight, but generally those plants are going to want that much sun. So generally we're trying to get a sense of where is there more sun, or where are we getting total sun throughout the day, and where is there less sun. So the way we can do this is what's called a sunshade analysis. And a sunshade analysis can be done a couple of ways. One of the ways is we can take transparency paper, and we can go every hour, 2, 3, 4, or 5 hours, all depending on the level of granularity we want within our information. And we'll take a base map of our site, and we'll go out with transparency paper, and basically for anything that's sunny, we'll use red. And for anything that's shady, we'll use blue. And we can do this with marker. We can do this with pencil crayon. Pencil crayon tends to work really nicely. And then what'll happen is every time you go out, you'll take another border of the sunny areas and the shady areas. And because of the gradient between red and blue, you're going to get a purple in the middle, and then you're going to have totally red, and you're going to have totally blue. And you can take every time you go out as an indicator of hours, and then you can get a color gradient of how many hours are sunny and how many hours are shady. So that's a really simple and easy way, just by pen and paper and transparency paper, to go out. You can do the same thing with a number of programs. These are mostly vector-based landscape programs. Things like Vectorworks or Landscape Architect does this as well. But you can also just do this all by taking the heights of different elements within your landscape, and then getting what's called the shadow ratio or the shadow angle, or just calculating the shadow. And so basically, if we have, it's the height divided by tan, or the angle of the sun during that period of time. So where I was living in Canada, I was 49 degrees in latitude, and the angle of my sun at that latitude was 17 or 19 degrees in the sun at summer solstice. And so at that point, I can work out what the shadow angle is, and I can do that in a number of different attributes and actually find where those solar angles are. This is getting a little bit into Rudo's question. And I can plot that out if I'm working at scale on my base map. So if I'm working on a grid paper on my base map, which is nice to use if we're drawing it out, if we're using digitally and we've got digital rulers that are scaled, we can plot out, depending on the time of day, where the angle is and where it lands on our site. So generally, those are some of the types of things that I'm doing when I'm taking a look at microclimate. But the biggest aspect of all of that is actually going and walking the land, just being in the land throughout the season, being in the land during certain times of days, and really feeling the landscape. Years ago, when I was a kid, I enjoyed shaving my head every once in a while during the summer, because it was just so cool in terms of the temperature. And it was so fascinating, because when you have a lot of your skin available to the elements, you really do feel thermocline changes as you're walking down and through a landscape. If you're coming down into a valley, you really feel that temperature differential. If you're coming into a thermocline, which is generally sort of a central band that comes across the landscape, you're feeling that change of temperature. So what I would say, Michael, is if we're looking for solar aspects, more than 6 hours, getting into 8, 9, and 10, I would say that's a lot of sun. Less than that, we're kind of getting into the partially shady 3 to 6, and less than 3 hours a day, we're looking at shady. In terms of temperature, generally, if we've got an area that's going to be, somewhere off of 30 to 40% of what the average temperature is in the day on the rest of the site that's open and exposed, that'll give us a sense of those gradations, but it is very subjective. There's not a lot of scale or measurements for that. So yeah, hopefully that's helpful. You've got 2 other questions here. In general, are lower flat areas considered to be wetter? Yeah, I think I covered that in terms of why that is. What's a good standard for classifying whether an area is wet? So generally, if it holds water and if it's kind of a bit marshy during pretty simple rains, or if it's marshy just all the time because of either a high water table or drainage that comes into it, generally that's what I'm calling wet low-lying areas. Or if it is indeed a wetland, if it's an entire different biome and ecology, I tend to call that a wetland outside of just wet. How do dogs fit into the whole picture, and what kind of caution should I take regarding farming with dogs in the family? So can you explain that a little bit to me? What do you mean the whole picture? What's your question specific to?
I actually wrote a little bit more right below what you typed.
Oh, there we go. Sorry.
Right. Yeah.
Look further down. Gotcha. I mean, what are ways I can design the site so my dogs and plants can benefit each other? I'm planning on letting them run freely in the lawn, which will become my zone 1-2. They'll be urinating and defecating, and I'm not sure if my zone 1-2 plants can survive my dogs. Should I set aside another zone for my dogs to defecate, urinate, and run around? Yeah. Okay. So great question. So generally, if we're talking domestic dogs, these are dogs that generally are not around farm animals and are not conditioned to be conscientious about training when it comes to being on an agricultural site. Usually we want to separate those areas out. Over time, you can train your dogs to stay out of beds, or at least we were able to train one of our dogs. The other dog was not as trainable. So generally, it's going to be specific to the dog and the situation. So I tend to keep them separate only because dog urine can be detrimental to plant growth. We can get these bald spots generally in lawns, and you can see this very much if you've ever done or worked with conventional landscapers, which was one of my very first jobs. I started a landscaping company. And so we generally want to separate that out. We generally want to have a place for the dogs to run and be if they're not trained or trainable. And generally, we want to keep them away from urinating and defecating on different areas. One of the problems with dog feces is that it can be problematic when it comes to composting. You'll find lots of stories everywhere, and there'll be some people who are like, I compost my dog poop, no problem. You'll have other people say it really sets off the compost. Every dog's different, every diet's different, so it's very variable. What I will say is that over the years, I've come to generally either have a small pit that I will put dog feces into, or I will use what's called a anaerobic digester, which is, in concept, it's basically some kind of vessel that's partially buried. That vessel usually has holes in the bottom of it, or is open at the bottom and has holes up the side for the areas that are buried, and then is usually totally encapsulated with a lid. If you've ever seen commercial varieties, they tend to be big green cones. But generally, we want to separate that out for a couple of reasons in terms of parasites and potential vector for disease, but also because of the composition of that feces. It tends to be problematic when we get into, composting, that we're composting to create biologically active compost that we're adding back into the garden. So that can be problematic. So generally, I would set them aside. Generally, I would compost in a different area. And generally, I would just have a dog run for them, is what I usually do. And if you've got 2 medium, large-sized dog and you're in an urban area, yeah, I'd probably just have a dog run for them. That's a little bit more for them than opposed to anything else. Years ago, I designed a dog park where we had anaerobic biodigesters all around the dog park, and then we had broadleaf plants and perennial and evergreen plants that you could actually grab a leaf, and the leaf you could use to pick up the dog poop and then put into the biodigester. And it was a way to move around plastic. So does that answer your question, Michael? Is that useful?
Yes, thank you.
Okay, thank you, sir. So Rudo, can you please elaborate more on sun position information in relation to permaculture design, especially temperate control in buildings? How do we use this information to design where our trees will be planted so they block the summer sun but let the sun in winter? Please direct me to any resources you know or a further study. Okay, so let's start off with the basics. So one of the most important things you can do when it comes to building design is ensure that the hottest sun of the year, whenever and wherever that is in your year, that sun cannot touch the building walls. This usually means that your eaves are going to be a little bit more proud from the wall. They're going to extend a little bit farther. And we can figure this out by understanding whatever the sun angle is during that time. So for most people in the temperate north hemisphere climates, we're going to have that during the summer solstice. In the tropics or in places that are more equatorial, generally we're going to have that same solar angle throughout the year. It's not going to change too much. As we move into the south, that's going to be more in the winter. Technically. But generally what we want to do is keep that solar sun. We're going to keep that, that sun. We want to keep that solar angle off of the walls. It just means having a nice big hat on your buildings. So sometimes that can happen with retrofit. Sometimes that can happen with new builds, but it's almost without exception, one of the most important things you can do to keep a building cool. The other thing you can do then is you can start to work with different types of trees in terms of their foliage and making sure that that foliage works with your climate and your climate change and the ecological change that happens with it. So within Canada, what we used to do is we used to have in a couple of our designs is we would have deciduous trees that would leaf out and were as tall as needed to be to shade different areas of a house or houses that didn't have good eaves. So that way the sun couldn't come onto the sides of the buildings. The dappled shade and and also the cooling effect of trees can really drop the temperature quite precipitously. In Cuba, we had an interesting design where the summer in Cuba was far too hot to grow annuals. And so what we did is we grew a number of moringa trees in between, also called the drumstick tree, in between the different rows with enough shade cover so that way they would grow out in the summer and would be dappled sunlight for our annuals. And generally annuals are pioneers and they're seedlings. So generally when we're trying to grow or create seedlings of any shape, size, or ilk, be they perennial, be they annual, be they deciduous, be they coniferous, if they're a pioneer, they generally grow in understory. So they generally like dappled sunlight. So they like to come up with that dappled sunlight. So if we are growing annual gardens and we're in arid or tropical areas, we tend to want to have that shade. So these moringa trees were able to shade out these annual gardens underneath during the summer. And then during the winter, they were cut for leaf and they were just basically pruned back. So that way they could have more sunlight. So generally what we're doing is we're trying to choose trees at height and foliage to occlude as much sun as possible during the hotter times of years. And then on the other end, we're trying to make sure that they drop those leaves during winter months. So that way we can get the most amount of sunlight possible to areas that we need. That's generally what we're trying to do. And I think I explained most of that in here. We talked a little bit about sun earth tools and the value of understanding that solar angle, because then we can get that solar ratio. And one of the resources, if you don't have this book yet, I cannot recommend it highly enough. This is the Rainwater Harvesting for Drylands and Beyond, Volume 1, Volume 2. There's just so much good information in Brad Lancaster's work. But basically, Brad put together an amazing shadow ratio and sun azimuth angles for the latitudes, either north or south. So this is the latitude north or south. So for me, I was 49 degrees north. There we are. Oh, it doesn't go across. That's okay. I'll use my formatting tool. So here I have all of the different angles, and this is at noon. I think this one is at, this was 9:03, so this must be 10 and 2. So 10 in the morning, 2 p.m., 9 in the morning, 3 p.m. Because basically as the sun comes up, we're going to have a different angle. And so this is that angle that I'm trying to design around during solstice. I'm really trying to make sure that I'm using that angle correctly. And this is why when you get to the cross-section design, this can be a really valuable element to put into your cross-section, is to show where those angles are. And so if your cross-section is north to south, that angle will just be from the south to the north. And if your cross-section is east to west, excuse me, if it's east to west, you can actually show those summer angles, and also the summer angles in the morning, at noon, in the afternoon, and really show how that shades out. And I do this for anything I do in production. So if I'm ever designing a production system, I'm going to place everything out on my to scale map. I'm going to bring in my my shadow ratio, and I'm going to sketch out the shadow. I'm going to plot out the shadow around my tree using heights at maturity. So for simple math, let's call it 10 meters, 10 feet, doesn't really matter. And then I'm going to use that ratio to understand, okay, well, how much shade does that cast as we're moving into the summer and into the winter, and have I placed my trees appropriately so that way the sun isn't shading unduly its neighbor, so that way I'm getting the most amount of solar real estate during those processes. And I think that was more to the point of, Rudo, your conversation about, how do we use this actually in design? The other thing to keep in mind is that south is our most powerful sun, usually in terms of its potential for plants. West is our second, east is our third, and northern or bounce light that comes off of that north is the least powerful. So generally I use my solar assays in that way. And so sometimes I will do a sunshade analysis if it's a small site. If it's a large site, I'm basically going off of my solar angles and I'm plotting those out either in cross section or on plan view. And then, yeah, there's that case study we talked about of Moringa. Does that answer your question, Rudo? Was there more you were wanting to know, or can I clarify anything there?
Yes, thank you. I think that covers a lot of it. I might have to do a lot more reading around the issue, but thank you for that. It sheds more light.
Wonderful. Wonderful. Thanks so much. It's a great question. And, there could be a whole mini course, I think, within the PDC about this. This is the one thing about having instructors like myself and the other instructors in this class, because we use permaculture as a tool in our toolbox. But generally, as I classify myself as a regenerative land designer, permaculture is just one tool. And I never learned about solar analysis in permaculture. I learned about it when I was working with Guy College as an instructor, and then as a designer for them. I was introduced to it via the Agrarians platform that works largely with Keyline design as created by P.A. Yeomans. And then working with some large scale farm designers, this was very important. So it wasn't necessarily something that was in the permaculture suite. So it's always a question of how much do you include into a survey course, and yet it's super useful when it comes to the design. So I really appreciate you asking the question. As you can tell, I can go on quite a bit about such things. Wouter, I think because we have a number of other questions, and because yours is so specific about your design and technical problem, I think we'll come back to it if we have some time by the end here. And if not, let's do a Zoom meeting and we'll find a good time to chat. And I think I have your email, but if not, feel free just to copy this and just send it to my email, javin@allpointsdesign.ca. Thank you, sir. Jimmy, I'm curious if we can go over soil testing a little bit. I'm sending samples in and was curious if there's specific things I should be testing for that I currently don't. Since our operation is semi-hydroponic, I've leaned more on plant tissue analysis than soil in the past. Do you often recommend anything beyond complete lawn and garden from LNA, from A&L? I've often heard of the Haney method used for organic testing. Is that something we should use as well? As an addition, Affinity just released new programs and has a discount for them for folks that want to look at the design program. Awesome. curious what the new programs are. But yeah, they tend to run sales quite routinely. So yeah, so let's talk about soil testing. Great thing to talk about. So when it comes to soil testing, we have to be conscientious about what we want to test for. We can definitely do, the complete lawn and garden, if I remember correctly, is you get texture, and they do a pH, and they do general elements. They do organic matter. I'd have to take a look at it. But that's generally what we're looking for. If there is a worry about having any sort of contamination or issue, be that runoff from agricultural areas, if we're worried that somebody has been overspraying either glyphosate or another type of product. I was just working with a woman in the north, and she had this incredible story about a brand new pesticides that had kind of squeaked through the regulatory body and was really becoming an issue for growth cycles of broadleaf herbs and forbs. So generally, if you're worried about something, you usually have to ask for an extra test. Okay, so we've got a few more things in here. So basic tests, of course, it has fertilizer recommendations, organic matter, phosphorus, potassium, calcium, magnesium, CEC, which is great, which is called cation exchange capacity, which generally tells you the potential for fertility within your soil. pH and buffer pH. I'm not as worried about pH, mostly because pH can change on a second by second basis throughout the day, up to 2 to 3 points in either direction. And so generally, when we're testing for pH, we want to test the same location, the same day of year at the same hour. And besides that, I'm mostly just adding organic matter. Analysis also includes, if we do the complete test, organic matter, phosphorus, potassium, calcium, magnesium, sodium, CEC, and then we have a few others: conductivity, boron, copper, iron, magnesium, sulfur, and zinc. Manganese. So what I would add to that, and you might want to ask them, I know in Canada, A&L would do what's called a fungal to bacterial ratio test, and I usually have to ask for it. But a fungal to bacterial ratio test is a great way to start to get a sense of what is the biological activity that's happening in the soil, without having to send it specifically to a living soil microscopy technician that will basically look at your soil and start to do counts of fungi and bacteria. And that ratio gives you a sense of where you are in terms of succession. So generally, if we've got high bacteria, low fungal ratio, then we're early on in succession, we're into a disturbance. And generally, we're going to have to move that soil more so towards a fungally dominated soil, which is more akin to woody plants or forests or food forest or orchards or agroforestry. And usually the way we move in that direction is we feed the soil those types of microbes. And this is where things like aerated compost extracts and teas come into application, where aerated compost extracts are for soil, aerated compost teas are for application for foliar sprays, so onto leaf. And generally what we'll do is we'll feed them specific types of materials to encourage fungal development as opposed to bacterial development. So yeah, in terms of microbiology, they usually don't have something like that directly on their website. Usually you have to ask for like a fungal to bacterial ratio. But you can definitely do a Haney method or a respiration test to understand more about organic matter and CO2 respiration. But it really depends on why. Like, why are you testing? Are you testing to have a benchmark, like a base level data? And if you're doing that for base level data, I would recommend what you have here in terms of probably the complete test, only because you are going to get boron, copper, iron, manganese, sulfur, and zinc. And I would add aluminum. So generally, we're seeing more aluminum in soils. And basically, once pH gets to a certain level, aluminum becomes bioavailable to plants, and it's highly toxic. So sometimes the issues with our areas is that we have aluminum, and that aluminum now becomes bioavailable because we get to a certain pH. And I think it's a pH of 3, if So I'll have to take a look at my notes.
The place that I'm curious about is an old hayfield that we're thinking about planting trees in. So I guess I wasn't sure about, and most of the property is essentially this old hayfield. So the sample is in a specific location. And I guess I wasn't sure if there's some specific tests that I should be looking at because the trees are going to go in the next, hopefully, year.
Okay. Yeah. So if I was going to be planting trees, are you planting them as an orchard or shelter belt or agroforestry, silviculture? Like what's the trees? What's the?
So we're getting a grant that's like a harvestable buffer from the state.
Okay.
And I would like to do a combination of sort of a shelter belt with some food forest sort of built into it, I guess.
Yep.
And it's also to sort of block a view of a neighbor's house. So that specific area, I think would be a combination, but with some food trees as well.
Okay. Yeah. Okay. So an edible shelter belt. So basically a hedge that's functioning as a fedge, as Jude Hobbs would talk about, who's an amazing hedgerow designer and did a great course with us at Regenerative Living. Yeah. So if I was doing a test like that, I probably would want to get a fungal bacterial ratio and just generally understand what's in that soil to start off with. And I would probably do a glyphosate test. Unless you're in Wisconsin, unless you have a sense that they've been using other types of pesticides or insecticides in the area, in which case I would probably want to know if those were there. So I would basically ask around in your community and see generally what people are applying on hay.
Well, yeah, we've been here for 10 years on that land, and that's organic in the back, but I don't know, is 10 years a long enough period that you wouldn't worry about it?
Not for glyphosate. I probably still test for glyphosate.
Okay.
It's an easy enough test and it tends to persist in soil, regardless of the fact that the manufacturers say that it doesn't. I've seen glyphosate in soil tests that were 20 and 30 years after application. So I'd probably still do glyphosate, but unless there's anything else that seems super persistent, I'd probably be enough. Is there any issues or worries about heavy metals in the areas? Any sort of runoff plants or anything like that?
No, we're in a rural area and at the top of a ridge. So I think that's probably fine.
Yeah. Yeah. So I would say your complete test is fine. And I would add to it, if it were I would add fungal bacterial ratio, if they're able to offer that. And then I'd probably, A&L in Canada was doing a nematode count as well. And you may want that just to understand what the nematode population is. And then I'd probably add a glyphosate test to it as well.
Okay, so and then the procedure for that is basically call A&L and say, hey, do you offer these three things?
Yeah.
Because the submittal forms don't mention any of those
directly.
choices,
Yeah.
right?
Yeah,
Okay.
just ask them. Yeah, great question. Thanks, Jimmy.
Thank you.
Okay, so can you discuss the key point of a hill valley, especially as it relates to the placement of a pond? Yeah, happily. So Keyline is a great love and fascination of mine. And so I'm going to pull up the Agrarian's Handbook. And there it is. And it's going to take me a moment because it's in the cloud. So it's going to download here. And then it's going to pop up. But while that's happening, I'll wax poetically on what the agrarians are and what Keyline design is. And the other thing I'll actually bring up is I had the opportunity to create a documentary a few years ago all about fire prevention and fire resiliency. And I had a great opportunity to kind of dive back into PA Yeomans and his incredible background and story and conversation, which was pretty remarkable. So I will put a mark here. Just give me 2 secs. I think it was about here. Yeah, okay. So I'm going to put a link here into your question, which is the point within the Facing Fire documentary where I start talking about PA Yeomans and his experience. And basically what you'll see in that documentary is that PA Yeomans was a geological assayer, an engineer, door-to-door salesman, and he started working in mineral assay and started to realize when he was in China and other places that the Chinese had an amazing ability to place dams high up in the landscape and to use them throughout that landscape. And after a traumatic fire that took out his farm and a number of workers and family members, he decided he was never going to be in a water poor situation again. And there's kind of conflicted stories about this, but basically he walked out into a landscape one day and noticed that there was a certain number of places within a landscape that were shimmering, were actually lush with water. And he realized that when we have areas in valleys that go from convex to concave, because in a valley, as we're coming down, there's that inflection point where we go from convex to concave. And just after that point, not at that point, but just after that point, is the point where if we have that percussive effect of rain that hits a soil bed and breaks it apart into sand, silt, and clay, and then is in solution. Once we hit that apex point, the inertial, or the not inertial, what I'm trying to say, the inertia within that material slows, and it has the ability to come out of solution and settle down. And this is what he called the key point of the valley. Now, there are a number of interpretations of his work that says you can have key points on ridges and can have key points in all sorts of places. As much as I like and appreciate Mark Shepard's work, unfortunately, he's misrepresented that in his book and in his work. Doesn't mean he didn't make a beautiful farm, New Forest Farm, and is an amazing teacher and all those things. But what PA said and what he described, and he's the one who coined it and termed it and all the rest of it, is not necessarily what Mark's saying. So the key point is in the valley. It's in a place where we go from convex to concave, but just after that point, also called the inflection point, and it is the place where generally the momentum that is within that water that has overland flow has a chance to settle out. And this is where we start to see clay deposits. I'm going to pop back into my files here and see if this has decided to download yet. No, it hasn't, because of course we're using Zoom. So there's no reason for it to do so. But I was actually looking at some of my Keyline PowerPoint presentations this morning, and so I should generally have them available. I'm just going to pull this up and see if it wants to open for us, because I can talk a little bit about it, because I think I pulled out a number of slides to talk about this. So let's get into the geology. Of course, as I'm pulling up something else, it'll come up. Okay, so PA Yeoman's created Keyline Design. And Keyline Design is a full farm design process. It is not just geometry. It is not just plowing. It has a lot more to do with the entire farm design. If anybody's working in large scale design, I highly recommend getting more training in Keyline Design. And the premier individuals who are working on this are the Regrarians, regrarians.org. They have an online workplace called Regrarians Workplace. And that Regrarians Workplace is where you'll have the most able and inquisitive and open-minded individuals that have a growth mindset that will work on these types of problems and these types of conversations. So I find as a professional working in this industry, it's essential to be in. So I'm going to pop over to the Regrarians Handbook here. And so this is geography, and you could buy the Regrarians Handbook at regrarians.org. Highly recommend you do if you're working in this type of work. And what PA had was this way of cresting and dividing up a landscape. And so he would basically get into what's called primary land units. These were land units that were their own watersheds. And so this is an area that has a watershed. And here we are where we're starting to get a sense of key points. So basically, if you're taking a look in person, we evaluate a key point differently than if we have a contour map. In a contour map, basically, we're taking a look at where the lines are close together, and when they start to flatten out, usually the second or third line after that flattening out is usually where we start to see the key point. And because landscapes descend as well, so we've got our top null here, coming down a ridge, coming to another null, descending down to another null, just like our hand, right? Our hand descends, so do to the key points descend. There's no such thing as a landscape where the key points are directly at the same elevation. This was both a mistake in one of the republications of PA's book and also in Mark's book, and I think he's fixed it. But basically, we've got these descending points in the landscape where we go from convex to concave, and just after that, in these valleys called primary valleys, do we have a key point? And basically, if we take a line off of that key point that goes basically halfway between what is the apex of the valley and the apex of the ridge. And so you can kind of see this here. We've got this key point, and I'm going to turn on a little drawing tool so I can start to highlight this a little bit more. And this is red, so I'll use orange. I'm just going to make sure this is a little bit bigger. So if we've got the valley here and the ridge here, then halfway in between that is where that key point, or pardon me, that key line will terminate. And generally, this was a sense of where we might start to take a look to place our first ponds within landscape, our first impoundments. And if we roll down here, we start to get a much more specific way of looking at this. So as we see this key point, and so here's that inflection point we can see here, and I'm actually just going to zoom into that. Roll over. So this is a great example. Here's our cross section, and here's our valley. So here's our convexed shape. I'm going to draw a circle just to make this point very clear. So that's our convex. This is our concave. So we're getting into a rounded shape and into a cave shape. And that's that inflection point where it actually changes. Now, just after that, and you can see how the contour lines are very straight up, very close together. Now we're starting to move down. And if you can imagine, this is kind of that point where if you were walking down this slope, you'd be walking tiptoes, and then you would generally start to go down onto the flats of your feet. And the moment you start to touch your heels, or just before, that's that key point. So that's the way to describe it if you're there in real life. Now, the reason for the key point and the key line was the key line was a place where if we took that key line and we transposed it down slope, equidistance, we would get what's called a keyline pattern or keyline geometry. And that keyline geometry, if you're looking at it, you can start to see that that keyline geometry starts high up in the valley and then crosses to be lower down on the ridge. So here we've got 40, 50, 60, and 70. I'm going to turn to red here, and I'm going to zoom in. I'm going to make this a little bit more centered. I'm going to move around my drawing tools. Okay, so we've got, go back to my drawing tool. There we go. So we've got our contour of 40, of 50, of 60, of 70. So this is high up here and this is low, and we're coming off a main ridge. So here in these primary valleys, we have our key point where we're going from convex to concave, and just after that inflection point, a place where water can slow down and drop off material, we have the key point. And that key point then has a key line that comes halfway out in between the valley and the ridge. Now, if we take that line and we transpose it down equidistant, so this is not on contour, you'll see that now we're crossing contour. And as we get down further and further with this herringbone shape, especially down here, you'll see that we're starting above 60. So this is line 60. We're starting above 60, call it like 62, and we're coming down to what ostensibly might be 57. And the idea is that if we cultivate on this pattern, we start to place trees on this pattern, if we start to plow on this pattern, if we start to use this geometry, this pattern as a cultivation guideline, what'll happen is over time, we will change the distribution of hydrology on this landscape. So normally, so we're going to go back here a few slides. Normally, when we have water flow on a landscape, this water flow is going to flow at right angles to contour. And this means that the primary valley is going to become saturated and the ridge will become dry. So what PA figured is that if we change that, if we started to create cultivation patterns that were high in the valley, and then those lines crossed contour and then ended up lower on the ridge, we started to plant along those, we started to cultivate along those, generally we would start to slowly move water from the valleys to the ridges. So basically we would start to hydrate the ridge, which is generally drier, but is more exposed and actually has more air drainage. So generally, if we were going to plant, some ridges are actually very useful in this way. And so this is an example here of what that pattern looks like as we move down slope. And then the second thing he said was we could take a ridge guideline, is what he called it. So generally, as this shape, this key line as transposed down slope, then connected with a primary ridge contour, we could then take that primary ridge contour and we could move it up. And that would help us to create the pattern we're working with. And this is a great example that Darren put together, Darren Doherty of the Agrarians platform, talking about how if you move on contour versus a standard grid versus mosaic and keyline pattern in terms of cultivation, what the potential benefits are. So if we take a look here, we've got, this is a mosaic, and this is usually how we see grapes laid out or orchards laid out, totally indifferent to what's going on in the landscape. Just we're going to put them there, they'll be fine. When we have contour planting, one of the problems with contours is that with contours, we have to have uniformed as much as possible distance in between rows because our equipment is uniform. So the tractor never gets bigger or smaller. The brush cutter never gets bigger and smaller. So generally what we have is we have these what's called stub rows or stubby rows because we can't have contours all the way across landscape that are equidistant in between each other. And then when you have a keyline pattern, there's a couple of interesting connections between the two where you tend to get a mosaic pattern in terms of the visual aesthetic that people really enjoy, but you also use the majority of the landscape. So Darren's little chart here shows that process of, you know, what's the row equidistance, what's the erosion potential, what's the water on ridge potential, what's the stem crop density. So absolutely, as you see here, standard grid has more crop stem density in terms of planting out, but it's not as useful for water drainage, for spreading water across a landscape. It's quite good for draining air. The aesthetics, depending on your aesthetics, we had a great conversation once about whose aesthetics, but generally keyline patterning has this opportunity to, when you take a look at what he called his home farm, this is an example he uses throughout the entire book, so you can come back to it. Depending on what you're planting, you'll see here that each one of these keyline patterns is different depending on what's being planted. Well, why would that be? Let's go back to our conversation about solar access and real estate. If we're working with big timber crop trees that are going to be quite large, we can't necessarily have rows that are close together because they need to have some spacing. Or maybe we're doing integrated harvesting and pasturing on these. So you have to change depending on what those cultivation patterns are. So this is a great example of the different tree rows and the different elements there. And then I think he goes into ponding. If I remember correctly, it's been a while since I opened the book. Yeah, and then he's going into sector analysis and basic surveying, solar angles, things that we were just talking about. So getting back to your question, you know, what's the key point? Why is it of value? And what do we do with it? The key point is the point in a primary valley that goes from convex to concave, the point just after it, the inflection point, where generally soil in solution has a chance to slow down, usually where we have clay layout. And it's usually, if we do end up putting a pond in here, it's usually where we'll excavate and get the most amount for our excavation. So if we excavate here, you can see how close these lines are. Let's say we change this into a pond instead. and let's say we take our, gotta put on my drawing tool. Let's say we take, you know, a dam wall here, the amount of volume of water we get there is more than, let's say, if we put it up here, because of the amount of basically incising we have of that valley. So this has also been a place to find where that ponding potential is. So once you've identified your key points and you've identified your key lines, usually on paper or in program, and usually we're using either Map Info or QGIS or ArcGIS to do the planning for this, then you'll get a sense of how much does it cost to move X amount of material, depending on your excavator or your moving company, and then how much water is being filled. And then once we have a sense of, okay, we've got 4 or 5 spots that we think are good, then we'll bring in a machine, we'll do an excavation hole, exploratory hole to see what kind of soil we're working with. Do indeed we have the clay to line this pond or potentially create a key line, a key way for our Keyline dam? And a key way is basically a way to put in your wall material into a substrata of clay, so that way it's locked in. It's a whole other conversation, but everything leads from one to another. So basically that key point is the place to where we can create cultivation patterns that move down slope, and then they can join with ridge guidelines, and then they can move up slope, and then we can have this patterning that generally goes, again, starts up here in the valley and then crosses and comes down slope on the ridge. And again, what kind of patterning, or pardon me, what kind of cultivation do we put in there? Depends on what we're growing, depends on what we want to grow, depends on what's useful for that area. So like Jimmy was just talking about potential hedgerow that might be for privacy or might be for wind. Well, it could potentially be planted on a keyline pattern, depending on the usefulness. And one of the photos, I don't know where the heck it is, but one of the photos that Darren used to show was this ridge that had started to go glassy in the mornings because of the amount of moisture that had accumulated on it. And it was mostly due to the fact that the trees that were planted along the keyline pattern of cultivation, their roots, were acting as a pipe drain. And so water was traveling along these roots. But again, that water was traveling like maybe, you know, an inch or 2 inches. It wasn't traveling that far, but over time you have all of this little water precipitation that's moving this way. And the ridge was actually getting wet. And this is the great genius of Keyline as created by P.A. Yeomans, is that it, through time, effort, biological process, moves moisture towards that ridge. And this is where the pattern for keyline plowing, keyline plow being what's called a shear plow or chisel plow. So basically, as it comes along, it lifts, shears the soil, but it doesn't invert the soil as a lot of what we classically think of as disc plowers do. But basically, on that shearing, when you come behind it and then plant in it, which you have to do right away, it then opens up soil, creates root depth, decompacts, and generally, again, that water that comes into those little furrows is only going to move, you know, microscopic, but generally over time and over landscape and over scale, all that water is moving towards ridge. Daniel, probably far too much information from what you were asking for, but
no, actually it wasn't far too much, but I can guarantee it'll take me more than just a minute to digest it. The Gregarian handbook that you're referring to, is that something we can get a copy on that website?
Yep. Darren sells it. He only sells it digitally right now. They're still developing the final few chapters. They got an angel investor, I think last year or the year before, to finish it off. So he's working with Andrew Jeeves, who illustrated the Permaculture Designers Manual. And I think within the next year or so, it should be completely done. And I would imagine in a year, you'll be able to buy a physical copy. He originally thought it would be this great little handbook that you could put into your pocket, but Darren is a perfectionist completist that wanted everything in it. So it's a beautiful volume, has wonderful information, and especially if you're designing roads, if you're worried about fire damage or fire spread, which I think you are, if I remember your site correctly, the calculations, the formulas, the general understanding is unequaled with all of the information that's out here right now. So I would highly recommend folks picking up a copy of whatever there is now. And we all kind of went through this together. We all bought chapters to try and support him. And I don't know what he's doing now. I don't know if the next 40% is going to be another, $10 per chapter, or if he's, I have no idea. But generally you want to support people that are doing good in the world. And Darren's definitely one of those people that's doing that.
And that's at the Regarians.org, is it?
Yeah, regrarians.org. And I'll actually just, I'll pull up my, my Regrarians. And of course, Regrarians Workplace comes up for me. So I'm going to go .org and I'm going to find it for everyone. So that way it's pretty clear on where to get it. Ah, there we go. Yeah. So I'm going to share my screen.
One last comment on that. We have a relatively flat, oops, wait a second, I got to plug my, we got a relatively flat, narrow valley, but very, very steep, like 40+ degrees on the sides of the valley. And I want to work on water harvest. We got some small springs, and I know this is going to be really helpful on trying to figure out the water harvesting part of it.
Yeah. Yeah. And generally as are you in Idaho or Montana?
Idaho. Well,
Idaho, yeah,
kind of both,
yeah.
but primarily in Idaho.
Gotcha. So generally in Idaho, I did a little bit of work in Sun Valley, and then I did some work towards the north there. Generally what we're doing, and this is right out of the Regrarians approach, is we want to hydrate, or pardon me, we want to vegetate all of our valleys. So basically we want to revegetate them. If there is an opportunity to put in a non-destructive impoundment, and this is an important piece because generally as we're getting to incised valleys that are quite incised, putting in any sort of impoundment can usually be destructive. So generally what we'll do is we'll do a small test of what's called a check dam or a weir dam, basically a leaky weir, which is a compilation of wood or rocks to basically slow the water that's coming down that valley. So that way that momentum is taken out of that water, so that way the incision can't continue. And sometimes when we have those leaky weirs, those check dams, we'll then dig out a swale, or we'll dig out kind of a drainage ditch that drops again down onto the ridge. But normally we won't, because that amount of water that's coming down, to pacify it, we need to keep it on level. So normally we'll have a swale that comes out from a check dam, and the overflow of it will be on the ridge. Again, trying to remove the inertia of the water in the valley and bring it out to the ridge. Now, on that swale is a great place to start revegetating. So if you're using native trees, if you're using pioneer natives, great place to revegetate on. And now all of a sudden we've broken that concentration into the valley, and we're now spreading it out onto the ridge. And if we do that in successive ways down that slope, what will happen is that water will naturally start to come out onto slope. And as we start to revegetate it, it will take that revegetation. Now, in between those swales, there can be opportunity now for potential revegetation for native forest, or for production forest, or even timber forest if we're looking at selective harvesting, or if we're looking at coppice agroforestry. So if we're looking at cutting down certain areas of the tree for cut and come again growth, where it will come again. This is the brilliance of Mark Krawczyk's new book, Coppice Agroforestry, and the course that we've just launched. That's going to happen in January, where we can actually cut trees in terms of their stooling effect or their polewood effect for the size and area we need. The other thing, which I think we talked about last time, was live staking. And so if in those areas, especially in those areas, once after post, probably I would do a check dam, and then depending on the site, I might do a series of live stakes of some type of water loving live staking material, be it willow or alder or red oaks or dogwood. And that just starts to shore up those sections, and that weir dam then creates a little bit of a wet area that can then support those live stakings as you're moving down slope.
Yeah, the live staking is something I'm definitely looking to incorporate, especially on the super steep slopes, because really, and we have the only livestock we have in the property are elk, and they tend to be very destructive on any kind of a ditch, so we would want to replace.
100%.
So we have to work out with that in mind.
Yeah. So one of the things you can do is what's called jackfall. And jackfall is basically, if you have a new planting, you then place large logs at skewed angles, kind of like pickup sticks. When you drop them, you're basically creating an area that elk will not want to go because they can't navigate it. They can't get in there. And so instead of creating fences and all the rest of it, you basically create areas if you've got the space for it, right? This is the difference. If you don't have the space for it, you go for a fence. If you have the space for it, you're basically falling trees in this mishmash pattern around. So that way the elk don't want to come towards it. And when we're doing things like low-tech erosion controls, where we're trying to slow water, pacify water, things like the check dams, we're talking about the live staking, that jackfall can be the difference between that surviving and actually establishing, or it being just stripped bare from grazing herbivores like elk do. This is coming from years of trying to have hay that's protected for our horses in the winter, and the elk come through, destroy the barn and raise the hay and it's gone. So that kind of jackfall can really deter elk or any grazing ungulate.
Well, they say the problem is the solution. You saw in my initial project where I talked about the Black Swan wind event that took out about 40 to 50 or 60 trees up steep on the steep hillside, which we haven't dealt with yet.
Yeah.
That may be a real interesting solution to some of this.
Yeah, wonderful. Wonderful. Yeah.
Okay.
Yeah, great.
Okay, would you mind if we talk further on this in another episode or offline?
Yeah. Or if we want to go through this a little bit more in depth, feel free to drop me a line, Javin at All Points Design, and we'll have a private Zoom session and kind of walk through the water layer for you.
I'd be very interested in that.
Yeah, just send me an email. Happy to have that conversation.
Thank you very much.
Yeah, you're welcome. Great question. Thank you. Okay, back to Woder. Are the Zoom recordings that have been posted during a non-office hours week privately organized with a student? Just wondering if I'm missing something here. Yeah, so Woder, sometimes, just like I was talking with Daniel, we'll do a one-on-one session, and depending on the student and the situation, I'll ask if it can be publicly available. I think that's what you're talking about. And so those that they're comfortable with and it's a good conversation and it doesn't drag. Sometimes I imagine us going through the nitty-gritty of what happened with your assignment and with things being misaligned. It doesn't make for a compelling video to watch. You're watching somebody open and close things and move things around. And so sometimes it doesn't always work, but sometimes those mentorship sessions are basically just students having a problem and us having a quick chat or a long chat as it might happen to work it out. So that's where those videos come from, and that's why they're posted. If that was your question, I don't know if I answered it correctly or even understood it as I was supposed to. So, let me know if that was an issue. Thanks. Okay, awesome. Great. And yeah, please do email me, Woder, and we'll have one of those sessions one-on-one to sort through that issue. And I know you had a couple of other questions, and that goes for everybody in the course. If you're struggling, if there's something you just want to ask, if you want to run a design idea by me before you submit it, feel free. Happy to jump on a quick 20-minute Zoom call and go through it. It's super fun to go through those processes and have that time. Well, look at the time, 2:04. Well, I didn't go into my 4-hour ramble about Keyline design, which is good because we would have been here for far longer than I think we wanted to be, but I can. So if anybody wants to have follow-up questions for next time, please do. Please do put your questions down as you have them. It's brilliant to give me some time to precog about them and to find resources because I've got a fair number of years that I can add to this. But thank you so much for your questions this week. It was great. Nice to go into all the detail. And again, any questions, comments, queries, feel free to drop me an email or send me a note on Canvas. And really looking forward to seeing your next assignments. So thanks very much, everybody, and we'll see you in the next one. Take care.